All right, guys, let's move on to the next topic here, finding the angle between two vectors. Okay, so the last video we learned how to find the dot product of two vectors, and we learned how to use the dot product to see whether two vectors are orthogonal or not, 90 degrees. Okay, if the dot product is 0, that means our vectors are 90 degrees. But what if our vectors are not 90 degrees? There's some other angle, and we want to know what that angle is. Here's how we do that. So suppose I've got vector A and vector B, and I want to know angle theta between A and B. Okay, there's a simple formula for it. Here it is. Cosine of theta equals the dot product of A and B divided by the product of the magnitudes of A and B. So you take the magnitude of A, the magnitude of B, multiply those, and then take the dot product and divide it by that. And that will give you the cosine of the angle. Once you know the cosine of the angle, you can find the angle using inverse cosine. Okay. So why this formula might seem a bit abstract at first. It might seem hard to really grasp why that formula is true. So I'm going to give you a bit of a hint as to how that formula is proved. And then if you want to see the rest of the proof, I'll just put over here proof on page 502 of your textbook. And it's just a few steps so you can check out the proof and see, okay, that does make sense why that's true. Okay, but here's how they do it. Very clever move. They take this triangle, actually it's not a triangle yet, they make it a triangle by completing this third side of the triangle here, and they make that a vector right there. Okay. Now what would we call that vector? We're not going to call it vector C. We're going to call it, well, let's see, what would we call it? It looks like if I start at this point and I follow along vector A, and then from vector A I add on this dotted vector, I'll end up at the endpoint of vector B. So remember, when you add two vectors, you take the tail end of one vector and attach it to the point of another vector, and that's how you add two vectors together. So A plus mystery vector equals B, right? Therefore, B minus vector A will equal mystery vector, this mystery dotted vector. So you can call this B minus A, okay? And then we would know, if we knew B and A, we could calculate B minus A by just subtracting those two vectors. So we really know all three vectors of this triangle, and we could figure out the magnitude of all three vectors of this triangle just by using the magnitude formula. Okay, so we have a triangle where we know the length of all three sides when we find the magnitude of those vectors. When you know all three sides of a triangle, and you want to know one of the angles in that triangle, what do you use? Seems like we've learned something like that already. Yes, we have. The law of cosine. Okay, you use the law of cosine on A, B, and B minus A. Remember, the law of cosine is that fancy version of the Pythagorean theorem. A squared plus B squared minus 2AB cosine of C equals C squared. But here, instead of C, it would be B minus A, or the magnitude of B minus A. And instead of capital C, we would have theta in there for that angle. Okay, so if you remember using the law of cosine, that's how they prove this formula. They start out with that, and then they just do a few more algebraic steps, and then you end up with this formula over here. So this is really just a version of the law of cosine. Okay, and you see the proof again, like I said, on page 502, so you should check that out. Anyway, let's use our formula. This is the big idea here that you need to write down and use. You're not going to have to prove it on a quiz, but you will have to use it. Okay. Let's use this formula to find the angle between P and Q for the same three pairs of vectors we had in the last video. Okay? In the last video we had these three and we just used the dot product to see if they were orthogonal or not. Here we're going to use this formula to figure out what is the angle between these two vectors P and Q. Okay, so let's start with part A. Let's see here. I want to find theta, the angle between them, and I know that it's the dot product of P and Q over the product of the magnitudes P and Q. Okay, well, in the last video, we already calculated the dot product of these vectors, and we got 0. Okay, and I could find the magnitude of P and Q, but I'm not going to, because I know that whatever is in my denominator here is not going to be 0. So I'm going to have 0 divided by some positive or negative number. Actually, it would have to be a positive number, wouldn't it? Yeah, 0 divided by a positive number. I know my answer there is going to be 0. Okay, so I have cosine of theta equals 0. Now, if you know your unit circle, you know what theta is. Okay, you know that theta is 0 degrees. Theta is 90 degrees, right? If you think about your unit circle, you know that up here you have that point 0, 1, and you know that theta is right here is at 90 degrees, and your x value there is 0, so cosine of theta is 0, so you know that you're at 90 degrees here. Or if you want, you could go to your calculator and just ask it, what is the inverse cosine of 0? And it should tell you 90 degrees. Okay, so we have theta equals 90. Are we surprised? No, because we knew from the previous lesson, the previous video, that when they have a dot product of 0, they are orthogonal. And remember, orthogonal means perpendicular, which means they intersect at a 90-degree angle. So really, we just proved, if we can prove this theorem, then we just proved the last theorem, that if the dot product is 0, then the cosine of theta is 0, which means theta is 90, which means the vectors, are orthogonal. Okay. So what about B and C? Well, when we do part B here, we use the same formula, P dot Q over the magnitude of P times the magnitude of Q. Here, let's look at my notes from last video. P dot Q was equal to 36. So cosine of theta, P dot Q is 36 over, now we have to find the magnitude of P and the magnitude of Q. And if you remember how to find the magnitude of a vector, you just do the Pythagorean theorem on the two components to find basically the hypotenuse there of each vector to get the length of each vector. So I'm finding the magnitude of P would be the square root of 2 squared plus 5 squared times the magnitude of Q, which would be the square root of 8 squared plus 4 squared. Okay, so cosine theta equals 36 over square root of 4 plus square root of 29 times square root of 64 plus 1680. Okay, cosine of theta is 36 over root 29 times root 80. Now, we could multiply the 29 and the 80, and then we could rationalize our denominator to get this thing in simplest radical form to leave it precise. But what we want to do is we want to find the inverse cosine of this value so that we can get to theta. So really, I would kind of be wasting my time simplifying this expression, since I'm just going to find the inverse cosine of that anyway to get a decimal approximation of the angle. So I'm just going to skip that part, and I'm going to do theta equals inverse cosine of this expression. I'm just going to go to my calculator for that one. Inverse cosine of 36 divided by square root of 29 times 80. 41.63. Now, does that answer seem right to have an acute angle like that? Theta is roughly 41.63 degrees is the angle between those two. Well, 2, 5, that's in quadrant 1. 2, 5, that's probably like that. And then 8, 4, 8 over 4 up, so that's probably that vector. So yeah, I bet since those are both in the same quadrant, that angle is an acute angle. So 41.63 degrees seems reasonable. Okay, always good to double check. Does that angle seem reasonable to us? Is it supposed to be acute? Okay, yeah, since those vectors both come out in the same quadrant, 2, 5, and 8, 4, that angle is going to be acute, so that answer makes sense. Always good to do a mental check. Okay, so we've got two perpendicular vectors. We had theta of 90 degrees. Now we have two vectors that intersect at an acute angle. And let's see what happens with part C here. Okay, I'm going to use the same formula. Cosine of theta equals P dot Q over absolute value of P. Not absolute value, sorry. Magnitude of P, magnitude of Q. Last episode, we calculated the dot product to be negative 492. So cosine of theta equals negative 492 over, this is going to be a long over, the magnitude of P, which would be square root of 1 squared plus 9 squared. Actually, it's negative 1 squared plus negative 9 squared, but if it's being squared, it doesn't matter if that's it's negative, because it will just become positive anyway, right? Times the square root of 6 squared plus 54 squared. Okay, so cosine of theta equals negative 492 over square root of, let's see, 81 plus 1, that's square root of 82. times square root of 6 squared is going to be 36 plus 54 squared. 54 squared plus 36. 2,952. Okay, so I'm actually going to calculate, because I know how this one turns out, I'm going to calculate this denominator here. I'm going to take the square root of 82 times 2952, and we get positive 492. So I got cosine of theta equals negative 492 divided by positive 492, and I know that that is just equal to negative 1. Okay, so I have this equation, cosine of theta equals negative 1. If you know your unit circle, you know what theta is, right? If you go back to your unit circle here, where's the x value negative 1? Over here, you have that point negative 1, 0, and your angle theta is pi radians, or 180 degrees. Okay, so theta here, or of course you could go to your calculator, inverse cosine of negative 1, and we get 180 degrees. So theta is 180 degrees. So these two vectors up here are 180 degrees opposed from each other. So the picture would look something like this. Negative 1, negative 9, so that's this vector, and then 654, that's this vector. They have 180 degrees between them. These are called parallel vectors. Okay? When two vectors are separated by 180 degrees, you call them parallel. And also, if you have two vectors that lie right up on top of each other, like positive 1, positive 9, if you get an angle of 0 degrees, you also call those parallel. Okay? So in the quiz, there's going to be a problem that says, figure out if these vectors are parallel, perpendicular, sorry, not perpendicular, orthogonal, or neither. Okay? If you get a dot product of 0, you know that they're orthogonal, and you can stop the problem. You say, all right, okay, I know it's going to be 90 degrees. Okay? If you go through this and you get a cosine of negative 1 or of positive 1, these two answers will give you parallel vectors. Okay? Because a negative 1 will give you a 180 degree angle, positive 1 will give you a 0 degree angle. Both of those are considered parallel vectors. Okay? Wow, 12-minute video, longest one yet. Hope that helps, guys. I will see you in the next video. Bye.